Hello friends, this is Alvin, and today our topic of discussion is limits. Limits is a topic which is for 11th standard students, and we are going to discuss what limits are and how what is the concept is. So you get the understanding of the concept. It will be very easy for you guys to figure out how to solve any problem. So first we are concentrating on the concept itself. What is limits and what it actually means. Now limits, as you can see on the board, it is written as limit x tends to 0 function of x. So function of x, first we have to define what is we have to understand what is function of x. Function of x, as you can see, if I give a vague example, for example, if I say that bacteria they double every 1 minute. So for example, when I start a stopwatch, I start with one bacteria. After 1 minute, they are going to double and become 2 bacteria after 1 minute. So after 2 minutes, they are going to become 4 bacteria. So I'm sorry, I will just change it. After 1 minute, I'm going to get 2 bacteria. And after 2 minutes, these 2 bacteria are going to double and I'm going to get 4 bacteria. After 3 minutes, these 4 bacteria are going to double. Each bacteria is going to double. So every bacteria doubled, you get 4 into 2, it is 8, and 8 will get doubled, it will become 16, and so on. So I just want to find out a general solution. I don't want to find out each every second. So if I say if I think of after 100 minutes how much bacteria am I going to get, I just want an equation that is going to, I just put t is equal to 100 time t, it is equal to 100, and I'm going to get the answer directly. So such type of relations are known as functions. So see here, if I write here 2 raised to t, will it be correct? Number of bacteria is n, and 2 raised to t is the number of bacteria after time t. Now in this equation I am just going to put t is equal to any value I want, and I am going to get how many bacteria I am going to get. So let's check whether it is true. When t is equal to 1, n is equal to 2. When t is equal to 2 minutes, if I put here t is equal to 2, that is 2 raised to 2, I am going to get n is equal to 4. T is equal to 3, I am going to get 2 into 2 into 2 is equal to 8. So I am getting all the values that I want, and this is the relation between number of bacteria and the time. So this is the relation. This is a simple equation that is going to give me, my life is going to be easy by using this equation rather than doing all these calculations. So instead of t, I am going to put any value I'm interested in, and I'm going to see how many bacteria I get. So there is a relation between these two variables. These things are known as variables. So this is independent variable. I can put any value I want. T is equal to, this n is known as a dependent variable because the value of n depends on the value of t which I put. It is not independent. Alright, fine. So in this way we define what is function of x. So function of x means it's a function, any function which is in this form. So there are many different type of functions, that is 2 raised to x, there are x raised to square, this is known as the algebraic function, and sin x, this is known as trigonometric functions, and so on and so on. The different functions that are, if we put the value of x, we are going to get some value. So functions are basically that. Now what does that mean, that x tends to some value? In this case it is x tends to 0. X tends to some value. What is the function of x? Like for example, it is saying that you have to take the value of x towards certain value, right? And as you're getting closer and closer to that value, what is function of x getting closer to? Like for example, we'll take an example. Suppose function of x is equal to x square minus 2. Right? As if I take limit x tends to 0, that is, as I'm going to put x closer and closer to, sorry, not 0, I'm going to just take 2. When x is tending to 2, so when x is tending to 2, what is x square minus 2 getting closer to? So I'm going to take x is equal to 1, 1 square is 1, 1 minus 2 is 2, and when I'm just going to put x is equal to 2 square minus 2 is equal to 4 minus 2 equal to 2. So my answer is 2. It's easy, right? So when x is tending to a particular value, that is x is brought closer and closer to 2, it is logical enough that x square minus 2 will go closer to the value 2, right? Because you are putting x which is closer and closer to 2, and when I put is equal to 2, it will become equal to this function is going to take the value 2. So that means as I am putting a value of x closer and closer to 2, it will move closer to 2. Not a big deal, right? Now we are going to just close it on it, and we are going to take some interesting functions. That is why limits is a very important part of calculus. This is because we are going towards a number that is the camouflage number. It's a number which is actually having, it can take any value. Like a camouflage is considered to be, if I wear a camouflage jacket, I go and blend into the surrounding. So in the same way, this camouflage number can take any value, and this value can be different, can be written as 0 upon 0. It is any value. For example, if I take 0 ones are 0, 0 ones are will also be 0. Another 0 upon 0 can be 0 ones are 0, 0 twos are also 0. So the value of this 0 upon 0 can also be 2. It can be 3, it can be 2.5, it can be any number. So 0 upon 0 can take any number. So this is very interesting from the point of view of limits. Because I am going to give you an example. We are going to solve a very small example, and we are going to see how this works, limit works. I am going to take x square minus 4 upon x minus 2. Now this is saying that when x tends to 2, so that is, if I take the value of x closer and closer to 2, what is this value approaching? This whole function, what is the value of that? So if I put x is equal to 2, what is going to happen is, it is going to be 2 square minus 4 upon 2 minus 2. This is going to be 2 square is 4 minus 4 upon 2 minus 2 is 0. So 4 minus 4 is also 0. I am going to get 0 upon 0. So I am getting the value 0 upon 0 because it's a camouflage number. Does that mean, what does that mean? It means two things. Okay, either you are ready to believe that x square minus 4 upon x minus 2 will tend or will move to any number, or you have to be ready to believe that there is some number that this mathematics is hiding behind this camouflage number. So can we find this camouflage number or not? That is what is our quest in the limits. Now see here what is going to happen. I am just going to say this is limit x tends to 2. I am going to restate this problem like this. Little bit of change in the viewpoint is going to help us find out which number this function is going to. It is certainly not going to every number on the number line, because this camouflage number means every number on the number line. So it is not going there. It is going to some one particular value. Okay, and that is what we are going to find out. So it is, I am just going to write this as x square minus 4 is, I can write this as 2 square, that is x minus 2, limit x tends to 2. So I didn't change anything, I just wrote 4 is equal to 2 square. So I know that a square minus b square, I can write it as a plus b into a minus b. This I can write. So I will write the same thing like this, limit x tends to 2, I can write as a plus b, that is x plus 2, into a minus b, x minus 2, upon x minus 2, and x minus 2 gets cancelled. Right? Now I can put x is equal to 2. So limit x tends to 2 is x plus 2. So if I put x is equal to 2, now my value is going to be 2 plus 2, which is equal to 4. So initially we had this function moving to any value when x will move towards 2, but now that we know we have cancelled out x minus 2 from these terms, we get x plus 2, that is when I put x is equal to 2, it will be 2. So solution of this problem is when limit, that is x will move towards 2, x square minus 4 upon x minus 2 will move towards 4. So this is what the limits is all about, and the function, the application of limits will tend to derivative. That will be the next topic, and that we are going to stay tuned for our next episode, and we are going to talk about derivatives, which is a far more superior concept and it is very misunderstood by students, and that we are going to clarify each misunderstanding, and we are going to do the concept of derivatives. Stay tuned for that topic. Thank you.